Hello, welcome. Please subscribe to our channel if you did not subscribe for more updates. And plenty of people ask give us two instances where it breaks the paradigm, the volatile qualifier. So it breaks the. I already given in my previous video that four instances. Anyways, I'll be doing it once again now with much better example. So a volatile, usually the value of a global variable changes only as a result of explicit statement in C function that is currently executing. The paradigm results when a single program executes from the start to finish, and everything that happens is an explicit result of actions taken by the program. There are two situations that break this simple paradigm, in which the value of a memory location might change outside the scope of a particular function currently executing, or beyond the control of the program. One is interrupt and two is input output ports. Anyways, we have couple of more which you can check it in the other previous video. Let's discuss only these two. An interrupt is a hardware requested software action. Consider the following multi-threaded interrupt example. There is a foreground thread called main, which we set up as the usual main program that all C programs have. Then there is a background thread called systic_handler, which we set up to be executed on periodic basis. For every 16 milliseconds, for example. Both threads access the global variable time. The interrupt thread increments the global variable, and the foreground thread waits for time to reach 100. Notice that time changes, the variable time changes value outside the influence of the main program. What happens is, this while condition here, without the volatile modifier, the compiler might look at the code, or especially these two statements, time equal to 0, while of time less than 100, and conclude that since the while loop does not modify time, it could never reach 100. Some compilers might attempt to move the read time operation, performing it once before the while loop is executed. The volatile modifier disables the optimization, forcing the program to fetch a new value from the variable each time the variable is accessed. That means it acts like a volatile variable, acts like a refresh. This thing go and fetch from the memory instead of fetching it from the register. Okay, hence it breaks this thing. So this usually happens with sharing access to the common global variable, here in this case time. And assume any port. Port A is an input port containing the current status of some important external signals. So the program wishes to collect status versus time data to these external signals. So these external signals may be reading from a continuous temperature sensor, or boiling, or some other sensor, where the value keeps on continuously changing. So the code goes like this: unsigned char data 100 hash define GPIO data port A data R. So port A data port has been assigned as volatile unsigned long pointer with the address. Void collect. So collect 100 measurements for 0 less than 100. So data of I will collect ith measurement of GPIO port A data read. Without the volatile modifier in port A definition, the compiler might optimize the for loop, reading port A once, then storing 100 identical copies into the data. Suppose we have a 32. If I am reading at the first instance, let it read. We are reading from an continuous boiling water temperature, let it be 32 degrees centigrade at one particular point of time. It may keep on changing as the heat is continuing, but what happens if you don't use the volatile variable? It copies only once into a register and keeps on copying into the data of 0 to data of 99. All the 100 instances it will copy the same 32 degrees centigrade. But if you use a volatile, it breaks the paradigm and goes to the memory location, fetches every time like a fresh copy of it from the memory, like a refresh button. So I hope I answered these two I answered the questions. For more, please kindly subscribe our channel for more updates. Thank you.